get started in about 5 minutes. If you could make your way to the presentation area, that would be great. Once again, we'll get started in about 5 minutes at 6:40. We're going to get started in about 2 minutes, so if you can make your way to the presentation area, we'll get started in just about 2 minutes.
I was going to say, like, my cousin is like,
James, did you start the recording? He got you.
All right, how's everyone doing? Excited to be back at in-person meetups or what? This is such a great moment for me, and I hope for all of you. It's been like 2.5 years since we organized the meetup, and what a welcome back. Thanks to James, thanks to Convex, thanks to Alex, This has just been a dream, to be honest. It's like, I love bringing people together. I love these meetups, and it's really good to see everyone come back together for this meetup at Convex. And tonight, we have 3 amazing speakers for you. We have Alex Cole from Convex, who's going to be talking about end-to-end reactivity. And we also have Ryan Carniato from Netlify via Solid.js, who's also going to be talking about reactivity, but with Solid.js. So we got a little bit of a theme going on here. And then wrapping it up, we're going to have Sumner talk about bun. He's going to wrap it up in a little bun for us, all right? So he's going to talk about the new and exciting JavaScript runtime, bun. But first, a couple of announcements. So this meetup is organized by Real React, which has now taken over the other React meetup as well, which I've been running for a number of years. We started doing meetups, turns into conferences. How many of you have heard of Reactathon? The San Francisco React Conference? Okay, I get a lot more hands here than I did when I made a presentation in New York a few weeks ago. So it's good to see that the San Francisco React Conference has some branding going on. And actually, we came back in person in May. We have one of our keynote speakers here tonight, Lee Robinson from Brazil. He kicked off the event, basically State of React. We had a ton of other amazing speakers there. Just want to show y'all what y'all missed. If you weren't there, does not count, but almost, yes. You get a special award for that, Theo. Yeah, so it was at this incredible venue in Orinda, which is just past the Caldecott Tunnel. We basically said Berkeley because everyone's like, what's Orinda? But it was just a phenomenal amphitheater. Everything was outdoors. Here's David Gorshit giving his talk. How many of you have seen this online? His talk is called Goodbye Use Effect. If you haven't seen that, give it a look. He said he's basically reading from the docs, but it's controversial nonetheless, and Theo can attest to that. We had so many amazing speakers there. I'm not going to go through too many photos, but if you've ever used React Router, you know this guy, or you know his code. That's Ryan Florence, co-creator of React Router and Remix. The sponsors had like these little tents. It was just so cozy and comfortable. And it was like under the sun, which was, we were very lucky because, I don't know how long y'all have been here, but I've been here about 10 years. And it's like, as soon as February ends, no more rain, right? It's just like done. We had rain like 2 days before this, and this is May, so I was getting a little scared. But thankfully, it held out. So that was a lot of fun. That was Reactathon. And you can see all the talks now at YouTube. Why is it not going to the next slide? If you go to youtube.com/realworldreact, all the talks are up now, so you can give those a look. Is it going to go to the next slide, or let's do this. Technology, hardware.
Yeah.
All right. If you've seen the talks on YouTube, you've probably seen this little animation at the start of it. This is Event Loop. What is Event Loop? So Event Loop is basically a production company that does the conferences such as Reactathon and others. But Event Loop is more than that. Event Loop is basically an application for managing and facilitating conferences and events. And it has the namesake Event Loop not just because the word event is in it and it manages events, but because it's intended to deliver a very different user experience. That basically solves a lot of problems that if you've ever been a speaker at a conference and you're doing everything over email, or you're organizing an event and you're sponsoring an event, everything is taking place over email. Wouldn't it be nice if a lot of these tasks were just automated? So that's why we called it Event Loop. Basically because of the name, but also because it helps to run things in parallel and make things more seamless and just faster overall. So that's what we're doing now. Right now we're operating in private beta. Basically we're working with enterprise companies to help them to run their events. We do the production for their events, and then we also help them to make it hybrid via the event platform, Event Loop. Also, speaking of conferences, Jamestackconf, which I was the original organizer for the first 4 years that it was an in-person event, is coming back in person this year, right here in San Francisco. They're at SVN West, which is right by Civic Center. Really great venue. And this year's event is going to be a full day of workshops and then a full day of talks. So this is a really exciting event. How many of y'all have heard of Jamstackconf? Yeah, so it started by Netlify. Netlify does it for the community, for the whole Jamstack community, for the whole front-end community. And if you haven't heard of Jamstack, I encourage you to check it out at jamstack.org. And you can even get a discount. So the React SF members, you can get 20% off using the code ReactSF. You can get that at jamstack.org/conf, or just go to jamstackconf.com. So take a picture of that, 20% off. It's currently in super early bird, so this is like the steepest discount you're going to get. Okay, enough of the announcements, yeah? All right, tonight we're going to get into the meetup. But first, I'm really excited to introduce you to the founder and CTO of Convex, our wonderful event host, James Cowan.
Excellent. Thank you for coming here, and thank you very much to Benjamin for organising. I want to also thank the speakers, Alex, Jared, and Ryan, and Cherie, if she's around here. Thank you so much for organising everything. You've done a great job. So, this is the Convex offices. We're a relatively small startup right now. We have about 15 people. We're growing pretty fast. And Alex is going to give a talk about reactivity. That's going to talk more about what Convex is. So I'm not going to talk much about Convex here, apart from the fact that we want to make kind of back-end engineering a thing of the past and really empower front-end engineers to own the full stack. And so we care very genuinely and very deeply about the React dev community. We care about being part of that community. That's why we're hosting this event here. This is actually our first meetup ever. This is, we just got these chairs put in a couple of hours before you got here. This is the first time using these speakers and this projector. You might notice it's a little bit warm in here, so apologies. We just didn't think through that the air conditioning would turn off at 6 p.m. So we think we have some fans showing up later on, but thanks for sticking with us. So yes, basically, look, it's really great having you here. I'm not going to give you a big sales pitch, but we are hiring. Go to convex.dev if you love this kind of stuff you hear today. We care about building a really, really awesome team of people who not only care a lot about this industry and this area, but also just good people to work with. And we work in person every day, just over there and over here. So with that, I'll turn back over to Benjamin and we can get some real technical content.
All right, thanks so much, James. Let's give a big round of applause for James and Convex. Okay, so before I introduce the speakers, I do want to let you know that they have all agreed to do Q&A. So after their talk, I'm going to run around and pass the mic around. If you want to have a question, please no pontificating, no gotchas, ask genuine questions, be nice. And then after all the talks are done, we're going to do 3 talks in a row. Once that's done, we're going to do basically topic tables. Basically, if you want to speak to one of the speakers about the content, they've also agreed to stick around here. You can come and chat with them in a little more personal level. But first, the first speaker we have is right here from Convex. It's a software engineer right here from Convex. It's Alex Cole. Please join me in welcoming him.
Thank you, Benjamin. Super excited to be here with all of you. This is like maybe 4 times more people than I have ever seen in this office before. Give me 1 sec to dick around with the audio or video. Oh, I got it.
You look at that. It's kind of
Okay, well, I guess I can start introducing myself first. Yeah, so I'm Alex. I'm a software engineer here at Convex, working on building out our global state management platform. Before I was working at Convex, I worked at Asana for 6.5 years, building Asana's in-house reactive data loading framework. So 2 companies now, both working on reactivity at the database level. So I'm really passionate about this kind of thing. So this talk, I want to talk about end-to-end reactivity. And I guess first up, what do I mean by that? We're all building React apps. Aren't they all reactive? Like, what is the What is the gotcha here? So I guess fundamentally, when I talk about end-to-end, oh, thank you. Not done messing around. You can tell that everybody else practiced their AV setup except for me.
That's yet to be seen.
Turn on screen here.
Displace it.
Well, we're just going to do it this way.
Yeah.
Is that percent?
Done.
Okay. Can't see it. All right, end-to-end reactivity. Yeah, I'm Alex, end-to-end reactivity. That's the thing we're talking about. Let's actually dive in now. Cool. So when I talk about end-to-end reactivity, what do I mean? If one user edits some state that lives in your database, all the other users in your app should see that state. Pretty simple concept. Today when people open apps, I think this is the thing they generally expect. But how do you actually build it? Right, we're using React, we're using a framework that makes it extremely easy to reactively update your views when the underlying props and state change, but that doesn't always extend to the state that lives on the server side. So in this talk, I think what I want to do is just talk through basically all of the different ways that you can add reactivity to your app and the sort of trade-offs that people encounter when they're building them, and where Convex fits in there. And I guess through this, I'm going to have a running example, which is a sort of simple app. This is called Let's Go. It's a little event planning app, so you can host events with friends, invite them, see their RSVPs, nothing too crazy. But it's a demo app that we built on top of Convex, and I think it has sort of enough functionality that it demonstrates where there's trade-offs being made in some of the different reactivity approaches. Cool. So first up, I'm trying to build this app. I need to, open the app, see the events that I'm hosting. The most naive, basic way I can go ahead and build it is to just use fetch, right? I'll just make an API on my server, and then inside my React component, I'll fetch the data. And the code to do that looks something like this. So I could have my app component. Inside of that component, I have an effect, and that effect just calls fetch and calls fetch on /API/events. A couple of lines to handle the fact that it's asynchronous, but nothing too crazy happening here. Okay, I built it. I can see my events. What kind of user experience did I just build? What does it feel like as a user of this app? So let's sort of walk through an example. So first up, I open my app, it calls that API endpoint, and it renders no events. That sounds good. I haven't scheduled any events yet, but I hear that meetups are happening again. I want to go schedule a meetup for some people to go to. So I go in here, I invite all my friends to this new React meetup scheduled for today, and I click OK. What happens next? Okay, it gave me the next page, but there's something funny going on here. Underneath there, it's still got that same blank state. Where'd my event go? I called fetch. I haven't done anything to explicitly re-request this data after I made my event, and now I'm rendering an empty screen despite the fact that I just built an event. And I think this is actually a really distressing user experience. Right now, you sort of lost some user trust because they're looking at a screen that doesn't have changes they just made. Obviously, I can go refresh. I can see that the event still exists, but I still think it's sort of not the user experience you're looking for. Okay, but we were being naive. We're just using fetch. I hear there's this world of data loading libraries I could be using instead. They're going to solve my problems, right? So, for example, my next iteration of my app could use SWR from Vercel. But here I'm sort of talking generally about this type of data loading library. React Query, for instance, has a lot of the same functionality. And I guess inside of my app component, dropping an SWR seems, saves me a couple lines of code, seems somewhat simpler than fetch, but sort of fundamentally the same. Use SWR, it gives me a hook. I can pass in the endpoint that I want to call in that hook. And then I guess the cool thing about upgrading to one of these data loading libraries is now it has some sort of like local store of all the queries I've loaded. And I can tell it when I do a mutation that, oh, I would like you to re-request this query. So, now in my create event component, here I have my component, and I have a mutate function, and when I decide to hit submit and actually go and like make that new event, I will tell SWR to go and mutate the API/events. And that means that when this mutation completes, SWR will go ahead and like re-request that endpoint. Cool, I added reactivity to my app, right? We're re-requesting it when I make a new event. Nothing's gonna go wrong. So let's go walk through what actually this feels like. So I'm once again at this screen. I click OK, boom. Now underneath there, you can see that my new event has showed up underneath because we re-requested it. As a user, I'm reassured my data got saved. I feel like I'm ready to use this app and like go and send this event out to my friends. So I copy that link, and cool. My friend opens it up. They know that they're invited to a meetup. And now they go ahead and click accept. What's the problem here? The problem is even after my friend goes and clicks accept on their computer, when I go back at mine, it still shows the same thing. In particular, that still says 100 out of 100 slots available, even though my friend is RSVP'd to this event. And once again, we're sort of like losing some user trust here. Like, users expect that when they have the app open, they should see the number of RSVPs change. They shouldn't be seeing some slots that no longer exist. And this is sort of the kind of bug that is just pervasive in apps right now. Even apps that are reactive often have this kind of thing where sort of some parts of the state are still showing you old data that you wouldn't get if you refresh the page. So as a user, yeah, I can still go ahead and refresh. It'll now show me there's 99 slots left. But fundamentally, I need to upgrade my setup. I really do want to show people the fresh data. Okay, but I'm in SWR. SWR has a tool for this. It's called polling. So an option here is that I can go and tell SWR to sort of just regularly re-request the data from that endpoint. And that way it'll be relatively up to date. This is super simple to add to my component. I just gotta add a refresh interval and tell SWR to, on every sort of, 30 seconds, go and make a new request. But do I want 30 seconds? Like, what should the time be? That's sort of a hard question, and I think that there's maybe not good guidance here. And I guess fundamentally, when you're doing polling, there's a trade-off. Like, on one hand, if I pick a time that's too rarely, if I only re-request that data once every 5 minutes, it's almost as bad as not polling at all. Right? As the user, I'm still going to feel like I'm seeing stale data. I'm going to be stuck refreshing the app and unsure about what's going on. But on the other hand, if I flip to the other side and I refresh too often, my database is going to fall over. If I do sort of refresh, once every second or something like that, now my infrastructure engineers are going to be on the phone with me, yelling at me about why 99% of our requests are for data that was just loaded that hasn't changed. And so here you sort of feel like there's a trade-off of okay, I can sort of trade off my user experience of do I want a live feeling reactive app, or do I want to save money and avoid paying for 10 times the size database that I otherwise would need. And I think if your app is small enough, you don't have very many users, this is probably fine. You can get away with this for some period of time. But sooner or later, if you're successful, this is not how you build scalable applications. Big applications today are not adding tons of polling into their code because it's an extremely inefficient way to build reactivity into your app. And I think at this point we've sort of exhausted the tools that the basic data loading libraries like SWR and React Query give you. Okay, I'm one of the big boys now. I want to go and build a real app that's going to be scalable and whatever. And maybe the tool that I decide to pick here is GraphQL subscriptions. And here, yeah, the example is GraphQL subscriptions, but I'm talking broadly about any of the event-based subscription technologies. So making the jump to GraphQL means I need to sort of change up my API in a few ways, right? I'm going to need to define a GraphQL schema. So great, I'll have a get events like query in GraphQL, it'll return my list of events, basically like how my API endpoint did. And then in GraphQL, there's a really big divide between the queries, which is how you load the data, and the subscriptions, which is what you listen for when you have the app open. So in addition to having this query, I need to separately define subscriptions that are going to tell me sort of that will fire every time this query changes. So in this case, maybe I'll make 3 different subscriptions, right? I want to know when new events are created. That should definitely appear on my screen, and I found it distressing when it didn't. I want to know when events are deleted as well. And I also want to know when events are updated. If people RSVP, if the event name changes, that kind of thing. This is a little more complexity than I'm having to add in my app, but it's okay, I'm willing to do it. I think reactivity is important. So I go ahead and build that into the front end. So in my now app, what do I gotta do? I need to load the data with the query, and then simultaneously, I need to go and subscribe to all of these 3 kinds of subscriptions. And then when they fire, I sort of need to update my local store with this state. And right now, I think this seems tractable. It definitely feels more annoying than when I was just using SWR, but that's okay. I'm willing to make the trade-off. I think the real kicker is when you go ahead and try to build the backend that is this GraphQL backend. So when I do it on the server, I need to now decide when to fire all of these different events to match the subscriptions. So when new events are created, I call event created. Good, no problem. I know where in the code that happens. Oh, and sorry, also my server now needs to get upgraded to a GraphQL server that makes a WebSocket and all of that, but we'll brush that under the rug. So when events are deleted, great, I'll find that line in the code, I'll fire the event deleted event, and push that to the clients when they need to know. And then when do I fire updated? Well, I guess I need to fire it when someone RSVPs, when the event name is edited, when the time is changed. I'm forgetting something. There's just way too many places that will update events. And as my code base and data model grows in complexity, there's going to be more and more spots where I need to fire that updated trigger. And in practice, this is just completely intractable. Even Apollo, GraphQL's own documentation, doesn't recommend using subscriptions for this kind of thing. Because as soon as you do this, you're unable to tell, your code base is a mess. And they recommend you just pull. But yeah, using GraphQL subscriptions or any of these event-based models is just extremely complex. Here we've sort of solved our performance problem by pushing updates to the client, but now we've turned it into this engineering complexity problem, where now our code base is just cluttered up with different code to manage all of the different reasons why I need to fire events. And I think for a lot of apps, this is where it stops. You sort of do some amount of polling, some amount of non-reactive data, some amount of GraphQL subscriptions, and you end up with a hodgepodge of reactivity models. But fundamentally, I think it can be just so much simpler. I'm telling the server what data I want to load. Why can't the server just tell me when the data changes? And that's where a reactive backend like Convex comes in. When you have Convex, you get automatic reactivity. So here's sort of a code snippet about what using Convex would look like in a React component. Here I'm using the Convex use query hook, which says that this component would like to call the getEvents query function. So getEvents is sort of this Convex query function that lives within your deployment on the back end. Just a function written in TypeScript. And then Convex knows what information this function loaded, so it can just push updates to you whenever it changes. So this sort of gets you the update pushing version that GraphQL had, but without you having to manually know all the times that you want to push these updates to the client. Because your database is sort of reactive to begin with, you don't have to think about it. Okay, well let's look at what this looks like in an app. So here's a little GIF I took of RSVPing. And you can see on the right is where my friend is has the tab open and they click accept. And the left here is another view where I'm viewing the events. And you should pay attention to that slots number, right? As soon as they click accept, they sync their change to Convex and run the mutation that RSVPs. Convex saves that mutation and then just notifies any client who's viewing the queries that depend on it and pushes the new query values to the client. And like, I actually, given the speed of this GIF, cannot actually see the difference between when accept is clicked and 99 changes. It's sub-second latency here. Cool. I'll let it play for a hair more in case you haven't gotten it. It's pretty exciting. I love this shit. Cool. But I guess what's the catch? Where are you paying for this? Is the backend function sort of crazy complicated to be able to power this kind of thing? And the answer is no, it's not. This is an example of what a query function inside of Convex would look like. So this is TypeScript code that you write that runs on the server inside of your Convex deployment. So here you're wrapping it in a query function to define that this is a query. I take in a user ID, and I use the Convex query builder to find events where the host field is equal to this user ID. Nothing too complicated. And this is cool because Convex understands the queries that I'm running inside this function and can push updates whenever any of them change. And I think the thing that is also interesting here is that these functions can sort of do arbitrary logic. So this is sort of the simplest example where a function runs one query. But it's just as easy to say, okay, I'm going to have one table that stores the events and another table that stores the RSVPs. And I will load my events, and then for each event, go and do a separate query for the RSVPs. And here, I can call other functions here. I can run many queries, load many objects. And once again, when any of them change, it pushes an update to the client. It's that simple. Cool. So what did we learn here? First, users expect reactivity. It's table stakes for apps today. People don't expect to have to refresh the page, and I think if you're using a hodgepodge of different reactivity methods, you're hurting the user's experience. Second thing, when you're using polling, you're making a trade-off between the reactivity quality you give your users and your infrastructure costs. And sort of part of this trade-off, one of them is going to lose. If you're using manual subscriptions, you're also making a trade-off. It's between reactivity and app complexity. Once again, you're going to have to decide, do I want a really great user experience, or do I want to have a code base that is free of clutter? Because either you're going to have to do a ton of manual work to make your reactivity work, or you're going to have some interactions where you're failing to update your client. And I think, reactivity, it should be automatic, it should be free. It shouldn't require any additional work from developers. Cool, that's what I got. Thanks for listening.
Right on. Does anyone have any questions? I can run in the mic to you. Starting with
lots of
the least outspoken person.
I have a lot of questions, but I'm going to ask the easiest one.
Yeah.
Type safety over network boundaries. When I call your used query hook, where is the type coming from, and how do I synchronize that with the backend function that I just wrote?
Great question. So I was personally, I'm a big TypeScript fan, and I personally wrote almost all of our TypeScript types. And basically, we use code generation and a lot of similar techniques, so it's code generation at sort of two different levels. So there's a way you can define your Convex schema, which is also in TypeScript. When you define the schema, we'll generate types for the DB that lives in query and mutations. So that makes sure that you only use filters that are valid, that you get the right document type back. And then we use it also at the level of your functions. So we'll generate types for use query and use mutation that are specific to the query functions that you've defined. Types basically end-to-end type safety.
Does that automatically happen with the string that you pass the hook?
Yeah, so we're using sort of TypeScript string literal types. So it uses just that string syntax, but it will give you the type that you defined in TypeScript. And that's, it's really nice too, because it means that you can get the same syntax in JavaScript and TypeScript. And also our code generation is cool, because you actually almost basically never need to rerun code gen. A lot of the changes it'll pick up automatically. Cool. More questions?
Over here. And then we'll come to you.
Good.
I don't know, so when you ran the query, you used JavaScript q dot equals and accessor attributes and things like that. So does that get compiled, like does that get statically analyzed and turned into some other language, or is that JavaScript run like really close to the data, like on the database node or something like that?
Right. So I guess the answer is that we do compile it down. So you're writing JavaScript code, we're running a like V8 environment internally, and then we turn that into our own internal representation that we use to actually filter the data. And it means that, yeah, I guess another interesting thing is you can just load all of the like documents and just iterate through them and find the ones where host is equal to something. But by compiling it down, we give you better performance. But you always have that like escape hatch if there's things our query language doesn't support.
Okay, we'll do one more question. So if you have a question that you didn't get to ask, just write it down. Alex will be here afterwards. So, Steve?
Thanks. My question is about whether there are controls over the frequency of kind of event emissions. Can you kind of coalesce events so that the front end isn't getting like a full fire hose of millions of back-end events being fed to a front end that can impact responsiveness?
Yeah, absolutely. So I think a few different answers here. Yeah, one is the server does some amount of this already. So the server will sort of transition the client to a like consistent view of all of their queries at a point in time. So if you make one change that updates 5 different queries on your front end, that will cause 1 re-render, not 5, because we're doing this thing where we sort of keep your queries at a consistent point in time. The other thing is that if you're using this for sort of things you know are going to be changing a lot, like a auto-saving text field, where every keystroke you want to save the new update, we're about to add like debouncing so that you can debounce those updates and make sure that they're not actually syncing on every keystroke, but you're syncing at a regular interval. And we're going to have first class support for that. Cool. Thanks everyone.
All right, let's give it up for Alex. While our next speaker is getting set up, the CTO of Convex would like to say a couple of words.
Hey everyone. I had to speak again. No, I just want to say that that was awesome, Alex, thank you. The people who wrote this stuff are almost all here, so if you see anyone with a red border on their badge, ask us hard questions, we'd love to answer them. Also, administrative-wise, if you're looking for the bathroom, it's out the hallway and around the other side, so just out there to the right. And drinks, food, help yourself, please.
Thanks again, James. All right, so our next speaker is going to be talking more about reactivity, this time with Solid.js. And we have the person we want to talk about, Solid.js, right here with us. He's a JavaScript performance enthusiast and a fine-grained reactivity superfan. He says he's obsessively passionate about the future of JavaScript frameworks. Fitting that we're at a React meetup then. We're talking about the future. He is the creator of Solid.js and the maintainer of Marko, which I'm sure he'll tell us a little more about. Please join me in welcoming Ryan Carniato.
Yeah, this is my first in-person event. Solid kind of got more attention during COVID, so this is definitely a bit of a change-up for me, and definitely interesting because, as you mentioned, I'm at a React conference, and I'm going to put some ideas up that might be a little bit.
Sounds great.
So let's get to it. What is Solid? Well, it's a declarative JavaScript library for building user interfaces. You've probably heard that before, like many that have come before it. And I mean, let's get straight to it. I wouldn't be offended if you saw it and thought it looked a lot like React, right? It values all the same things: unidirectional flow, read-write segregation, and mutable interfaces. And it's kind of built on the simple primitives. Have look like hooks, there's JSX, there's function components, and a lot of the same features. Portals, fragments, context expanse, transitions, and async streaming, concurrent rendering, progressive hydrating. It's a long list of things. So you might be thinking, okay, so React maybe. But, and this is a pretty big but. Solid is kind of nothing like React, actually, at least from where I'm sitting. I mean, this might be hard to believe. It's built entirely on fine-grained reactivity, similar to something like MobX and Vue. And the components only render once. There's no re-rendering of components. And there's no virtual DOM. In fact, like, it doesn't have any of that stuff. The whole mental model is completely different. A lot of the same values, but an entirely different implementation. What does that actually mean? Well, modern front-end web development for years has been about components. Class components, function components, option components, web components. And for good reason. Components are essentially building blocks that allow programs to be modular and composable. However, in pretty much every JavaScript framework, they have runtime implications. The update model and the life cycles are tied to them, and this basically has led to kind of like two views of the world. Either you use this top-down diff, kind of like a virtual DOM or type template literal, or you rely really heavily on compilation. And both of these really still rely on components that update top-down. And this kind of begs this question, when and what to memorize? Because if you're going to run these things over and over again, you don't want to redo work. And there's a great talk at ReactConf 2021 from John that addressed this exact thing. And your first inkling might be like, build your to-do app in a framework like React, kind of like this. Declare some state, wire it up, there's an event handler in there. And, but the one thing you have to remember is, anytime you change any state, it could be unrelated to this to-do list in here, you're going to be re-rendering the whole list in React. But that's okay. It's not that expensive. You have a virtual DOM, it protects you. But we still want to optimize. So what do? We apply some optimization. And maybe our app gets more complicated. We start passing state in from above, like maybe visibility props or maybe a CSS theme. So we add memo and use callback and use ref and dependency raise. And this code runs exactly the way you want it to. So we've accomplished our goal. But I'm going to say it's a bit of a departure from where we started from. So let's compile it instead. And to be fair, this isn't what you write. This is what the compiler generates. And this is pseudocode from an experimental compiler the React team is working on. But it isn't that different than what Svelte does. Like, basically, very, very similar idea here. You do a bunch of these shallow checks at every decision point, and when you rerun your component, when it's marked as needing an update. You can kind of see this memcache thing all over the place that is like checking, well, has this changed, has this changed? And we can do it like half a dozen different places, and now, instead of you worrying about it, some compiler does it. But it all comes down to this common ground, is that it's a component that updates. That we have to rerun it. Whether it's an update function or whatnot, we have to check against these memoized values. So what if we just didn't? What if we only ran what needed to be run and didn't rely heavily on compilation? What if the boundaries of our components didn't dictate the performance of our web applications? To do that, I gotta go back to the beginning, and I mean really far back to the beginning. So here we are. Hello world. Okay? We've done this before. You realize you got a variable, you set the variable, console log something. And it isn't long before you realize, well, we can change the value of that variable, and we can console log it again, sure, right? And then we refactor it into a function, because who wants to write console log over and over again? I mean, obviously it's a very simple example, but you get where I'm going here. Less duplication. But at a certain point, you start asking yourself, you're like, what if I just want to greet my friend here anytime I change the name? Like, I just don't want to do any of this. So that's where we enter into reactivity. And the first thing you gotta know about reactivity is it's based on primitives, kind of like promises. You just have this like simple construct that's kind of built in. And for our case here, we're going to introduce something called signal. And what is a signal? It's down there kind of midway on the screen. It is basically a get function and a set function. So now, in our console, we're actually calling name as a function, and otherwise we set the value, where we set friend for Mary. And this alone isn't doing very much. It's literally just showing the value that we wrapped over. But what if we introduce a second primitive called an effect? Basically, something that knows to listen to our signal. So now we create our signal, which is a reactive value, and we just tell it to call friend and get the latest value. What happens is the first time this effect runs, it runs hello John, and then when we call set friend, hello Mary in this case. So the second we set the second value, we are now logging flogging it. And if you've seen MobX review, it's kind of the same idea. And what's cool about this is you can extract it out, right? It's transitive. Essentially, if we wanted to, it's completely composable. Like if you wanted to make uppercase, so you wanted to make friend to uppercase, and now you call upper inside the effect, this all just still works. And you might be going at this point, well, what's going on? This is magic. Are you using compilation? I thought you said you weren't going to use compilation. No, this is completely runtime. This is using the runtime execution stack. And it's actually pretty easy. In fact, it's probably easier than that interview question you got asked on how to implement a promise. I can do it in about 50 lines of code, but I'm going to do even less to kind of show you what I'm doing here. Because a signal, as I mentioned, was a read and write that wraps over a value and sets it out. And that alone doesn't do very much, but okay, a little bit more code. I now have added a little bit here. I've added subscribers, and essentially, now when we read, we get a current observer. Don't worry about this yet, I'll explain in a minute. But essentially, if there's someone listening, we're going to just add that thing that's listening to our subscribers list. It's a set. We just add it. Right? And if, when we write it, now we just iterate through that list of subscribers and execute it. Okay? This is the one side. If the other side is its effect, and this is kind of where I'm going to show you what that other piece is. I'll put them side by side in a minute so it'll make sense, but essentially, we have a context, which is a global stack. It's just sitting out there in space. And whenever we create an effect, we just run this function that pushes itself onto the stack, runs the code you provided to your effect, and pops itself off. And the whole trick here is, because it's on the stack, anytime you read a signal at runtime, it knows, so it just subscribes to it. So, you know, if we run through our example for a second again, we created our signal, returns our read and write functions. Then we run our effect the first time. It pushes itself onto the stack. In the process, it calls upper when it runs the function. Then it calls name somewhere deep down in that stack. It's still all in the stack. It sees the context that was pushed on top when it gets the observer. And then it subscribes to it. Then it finishes running, so you log out the name. And then pop, it's done. Some point later, you write to that signal again. It goes through and calls execute again, which then pushes itself onto the stack, runs your function, grabs the latest value, because it's a getter, it calls the function, there's no closure here. Just calls the function, gets the value, console logs it again, and pop. We just do this ad nauseum. That's basically the whole process. Here's your reactive system right here. I know it's kind of ambitious to show people exactly how the framework works from a framework author's perspective, but that's what I'm doing here. And with that, we can build a whole army of primitives on top of it. Things like create memo to do expensive computations. Things like create store, which we have, which does proxies for deep nested reactivity, if you only want to care about little pieces of data that update. And things like create resource, which is kind of useful because it's like a built-in mechanism to do data loading and suspense, and it just kind of works like React query. But actually, that's enough on the fundamentals. I need to get back to my example, because that's not really actually the novel part here, because you can do a lot of this stuff. So what I want to do actually, and this is going to take a little live coding, so let's hope this all goes to my benefit here, is I went back to our simple example, and you can see that I'm console logging 0 and 1 in the console. So basically we have a signal, it runs once, sorry, yeah, thank you. And then again, we plus 1, and then we get the new value. But the thing is, why do we always use console logs to teach reactivity? Why don't we just do something like this, right? We could always, and I'm going to try live code here, which is lots of fun, especially now that the mic can actually hear me. And let's make an H1, right? There's no reason why we can't replace this here with, say, H1. This is just a DOM element, you know, x content equals count. Let's get rid of that extra thing. Yeah. And I guess I need to attach it, just because of the way, how should I put it, hot reloading works here, and I'm using vanilla JavaScript. I'm actually going to clear this out for a second here first, and then I'm going to go document, .body, .append, or h1, okay. And sure enough, we see here, and it says count 1. Now, that happens so fast, you don't even get to see count 0, because essentially, like, it just ran synchronously. So we're gonna need a button, and I'm gonna save myself from writing that button. So I'm just gonna jump to where I wrote the button in. But again, this is just vanilla.js. So we made an element, created an effect, one effect that updates the text, and then we made the button, and then we, on click, we did it. So I'm just writing vanilla.js, and our counter is a real life world counter here. I didn't need a framework or anything, really. I just had those, basically those 50 lines of code. Now, this is still a lot. Like, who wants to do this? Like, wouldn't it be just way better if we didn't have to do all this? Like this button here. I'm gonna start here with this button. Yeah, thank you, playground. Okay, you know, let's just push that down for a second. Wouldn't it be great if you could just write what you wanted to write here? Like, just, you know, like, I don't wanna do that, I don't wanna do that. Maybe this event handler, I could just hoist it up here and go like this with an on-click. And I just want to be able to do this, right? And I mean, if everything goes properly here, this should still work, yeah. And same here with this H1. We don't really want to do this with the H1. It's just too much. So let's make our header, and yeah, you can start seeing why I want to do this live, because I really wanted to show that we could just take basically our code here, and so far, the single effect that's updating that one piece of text, and just essentially kind of just erase the vanilla JS. And, you know, what if our JSX just compiled a tiny bit differently, just a tiny bit differently, so that we could have a working counter that is just working off an effect that updates one piece of text. And I mean, this is still a lot. I don't know who writes code like this. We might want to call it a counter or something, and then we can, you know, hopefully take all our code here, and no, I didn't do that right. This is the fun part about trying to look over my shoulder and think this out, as I said, live and all. And we should be able to, let's maybe prettier all this. Thanks. And then we can return maybe an array. That's our H1 and our button. And we should be able to just kind of spread in our calling our app. Counter, thank you. Yeah, counter. On completion. Yeah, and I mean, this should still, yeah, okay, it's still good, okay. And this is still like a lot of stuff, right? Because like, who does this? We should probably move this into here. We probably should move, sorry, I pulled that out, okay, where we are. Pull this, oh, come on. Yeah, okay, that's great. Prettier will fix everything. So we'll pull this into here and get rid of this. Probably still good, but honestly, let's just get rid of those two. Yep. We don't need the array. We need to get rid of this comma, and we need to close the fragment. But if we format this all right, get rid of that giant space, we should still have a working counter. Okay, cool. So this is starting to look like something you've probably seen before. But keep in mind that there's only one effect, updating one text node this whole time. So, I mean, if we jump ahead again, no, that's too far ahead. No, I don't get the jump ahead. Sorry, guys. I gotta do this one myself. This is an easy one, though. If I gotta do one more thing here, which is I need to import the stuff at the bottom, which is, we don't want to deal with that. So let's, sorry, you can hear my keyboard. And this one auto-complete that part. let's import render, and then we can essentially get to counter, and what did we say, document.body or something? That'll probably be good enough for our sake. And let's double check with the refresh that everything works. Okay, sorry, now we're here. Okay, thank you. And essentially, we have our one effect that renders, and we have something that looks very similar to what you've seen before. But I want to remind you all that this is just a function that we called once at the beginning. So if I put counter in here, you're going to see it in the console, right? But if I click this like a billion times, it's still only going to be logged once. And I mean, you can do whatever the hell you want in here, right? We can go what, set interval. Let's cause the world to collapse here, and set our count in here. What is it? Count plus 1. Sorry. Let's put it at a more reasonable timer, and let's refresh just to be 100% sure the hog reload isn't doing stuff with. Yeah, I mean it's not going to log again. It works exactly the way you would expect it to work. So okay. Almost done with this example, but I just want to point one more thing out because it's worth pointing out, is that what if I want to put 2 counters on the page? Well, now we log counter twice, and when we click each one, well, they maintain their own state because of course they do. These are just things, you just call a function, create something, and put it in. And what's kind of cool about this though, and kind of worth pointing out, is we've only got the 2 effects updating the count here underneath the hood. That's all that the compiler's doing. And this isn't like a re-render system or anything fancy. The component's just a function. So there's really nothing to stop us from just pulling it right out again, like where we started from. And now we have global state. Because it doesn't matter which one you click, it's the same reference it talks to. So this, as I said, this is not compilation, this is JavaScript. Like, this is just reactivity and real DOM nodes, because as you saw, we were just appending real DOM nodes. And that's all there is to it, really. Like, it doesn't matter, you can pass it in as props, maybe, like, see one updates by 2, and still double. Nothing reran. Like, there's no more console logs. Everything is pinpoint updates, but, I mean, as I said a moment ago, it does look like React, doesn't it? Okay, so yeah, where I'm going with this all is essentially there's a little trick to it. Our components, only the JSX gets compiled. So the whole trick is everything's lazy, everything's wrapped in functions. So when you come up with a component like our counter or greeting component, if something's reactive, or it could be reactive, we just wrap them together. So we just push that all down. The thing is, no matter how many components we build, there's only that one effect that we started with at the beginning, that one text node that gets updated. You can pass it through context, nothing re-renders. You can make the biggest tree that you want. And it's basically this little secret of the JSX compilation that does it. It's not like a heavy compilation, it's not memoization or anything. The code, you saw what the compiler generates, like I wrote it at the beginning. And the other one, the one that everyone's going to point to me, is like, wait a second. What about things like map? Like, because you're taking data and you're returning real DOM nodes. Yes, that is unfortunate because obviously that would be very, very inefficient if what we were doing was every time the data changed, recreate all the DOM nodes. So we do need helper functions for this use case. I don't think that's a terrible thing though, because this can lend to composition even more because, okay, I know, it's a for component. But can I show you, well, let me give you a real world example. Now, you've been using your Solid app and you made a for component, and then you're like, I need the paginate, or I need a virtualized list, or something. You don't want to run on the page. Well, what do? You import paginated, and oh, it's the same thing again, right? And this is the whole thing, right? When I talk about composability. Lists become paginated or virtualized lists. Conditionals become layouts. There's suspense or error boundaries. If you think about it, an error boundary or suspense is just an if statement. Just putting that out there. And the biggest thing is these are just components. This is not the compiler. If you do not like how Solid does for, write your own. Like this is not compiler magic here. We treat all components equal. So armed with this, we can actually go all the way back to the beginning of the presentation, okay? And I actually missed moving this window over. So let's see if I can do this. Okay, I'm going to pull this one across. I actually remade the app from Reactconf. And let's just flip that right here, right? And we're going to focus on the to-dos thing, because this is essentially part of the app here. We've got a component, and it creates some state. In this case, it's a deeply nested proxy. It's a store. We have some ability to update the done state on the store. Syntax might be unusual to you, but that's not the part to focus on. We have our for condition, and we have this get filter, which only shows the props visibility coming from above. And we also have a theme coming from above. And what I've done here in the console is kind of show some stuff. It was actually really hard to do this because so little changes in Solid. It was so hard to show what doesn't re-render. But I figured out a way by hijacking JSX properties. But essentially, if you change the duns, obviously the duns change. But the get filter doesn't get called again because it doesn't need to, right? Because why would you do that? And sure, if I change it and I change the filter, yes. What you're going to see here is that the filter is called, but the other to-dos weren't affected. To be fair, if I switch back, you are going to see both a filter call and a to-do call because the to-do needs to be recreated, right? Because you just added it back to the screen. But the thing I want to get at is, this theme color has nothing to do with the to-do list. Ooh, you know, we're not console logging into any of this as we move it around. It's all completely independent, and what's here is what's not here. Where's the memo? Where's the dependency array? Where's any of that? Where's the compiler even? I showed you, like, it was just what we were doing vanilla. This is very powerful idea, and essentially kind of the basis of what I've been building with Solid. So I talk about this as a reactive advantage. Components run once. There's no hook rules, there's no stale closures. Templates compile to real DOM nodes. So it's like this super low abstraction over the DOM. It's exactly, like you can always just escape hatch into it and like update some DOM element if you want to. And most importantly, state is independent of components. Component boundaries are for your sake, how you want to organize your code. Not for performance. The performance is good regardless, right? There's just those 2 component updates. So what I would say is, you know, maybe to experience the freedom yourself and give Solid a try. Thank you.
So what is the, you use the term fine-grained reactivity a lot. What does the fine-grained exactly mean here?
Yeah, I mean, the problem is there's so much types of reactivity. There's reactivity we talked about earlier with the databases. There's RxJS. I needed a term, and I was playing around with, and at some point I decided to call it fine-grained because it's all about many little signals staying in sync. The mental model is kind of like an electric circuit, actually, where everything it tries to get to steady state. And this is very different than like RxJS, which is about async transforms and like other types of reactivity. So honestly, it was just a thing needing a name. I don't know. Vue or MobX or whatever are in the same category, so they could, if they had a better name, they can too. But this is what I've been championing to kind of differentiate.
Anyone else? Over here.
Solid starts when?
Okay, yeah, no, that's a fair question. We've been working on it for like a long time, like 15, 16 months now. Solid Start, for those who don't know, is basically our meta framework. We've been building on top of Beat this whole time to build a meta framework. We're coming actually really good on a lot of our alpha builds. I mean, it's still super early, but the plan right now is a beta launch probably in August, beginning of September, I'd say, for a beta, so you can use it. You can technically use it sort of experimentally today, but it will change. It is available on Netlify, it's available on Vercel. We have starter templates and stuff there. It is there. It is just in a state where things are still changing. We're really working hard on the experience here to make sure that we can get it to where we want to be, to make it not just a meta framework, but a starter for all Solid applications.
Anyone else? We have time for one more question. Theo, you sure?
All I'm going to say is that the example where you move out the create signal is gold and you use that in all your presentations.
Yeah. Yeah, thanks.
All right, let's give it up for Ryan one more time. All right, while Jared gets set up, just a reminder that we are doing sort of like topic tables after this, so if you want to talk about Solid, Ryan's going to be here. If you want to talk about Bun, Jared's going to be here. And if you want to talk about Convex, look for the red badge. Alex is here, James is here, the whole team's here. So yeah, really excited about that. And I would encourage you to stay. You know, you can come here just for the talks. Obviously that's great, but you know, the networking, and we've all been on Zoom long enough. It's time for those face-to-face interactions. So I'm really excited for the final talk for tonight. We have the creator of the new JavaScript runtime, Bun, Jared Sumner. So please join me in welcoming Jared.
Bun is an all-in-one JavaScript runtime. Basically, I'm going to first talk about what is Bun, and then I'm going to talk about where it is now, and then I'm going to talk about what the priorities are, and then I'm going to talk about what's next. So Bun is designed to start fast. It's designed to achieve new levels of performance, basically be really fast at everything. It's designed to be a complete tool and also to be a drop-in replacement for Node. Bun dev is a front-end dev server. It starts in, sometimes it starts in like 1 millisecond. Typically it's probably more like 4 milliseconds. Bun installs npm packages about 20 times faster than Yarn. Normally on Linux it actually gets up to like 100 times faster, but I feel like if I say 100 times faster, nobody believes you. And that's specifically in the case of cached installs, like cached disk installs, where it's 100 times faster in some cases. And also if you're curious, you can if you pass -- backend, you can change the way it does the installs to see the different ways to make it, like, and see how that impacts performance, because it uses different ways to do the syscalls. Bun run starts package.json scripts 30 times faster. Basically, Bun takes around 6 milliseconds or less to start up, and npm run takes around 160 milliseconds or less, or more. This is a video from Twitter of just, also Bun has Bun create, which is sort of like Yarn create, but it's quite a bit faster. This is a video from Twitter where you can see that on the right, it's still going, and then he's typing very slowly on the left, and it's done. And then this video goes on for like another 30 seconds or so. Yeah, you get the idea. React in JSX is something I specifically optimize a lot in Bun. There's a React DOM server build in Bun that is 1.5x faster than the React DOM server browser build. This will become a PR to React, I just haven't had time yet. When adding readable stream support to Bun, I specifically optimize it for server-side rendering. There will be other use cases of readable stream, but I think server-side rendering is an interesting one to focus on. That benchmark there, oh, it is visible, good. This just compares the browser build with the Bun build. And this and a bunch of other optimizations makes Bun much faster in server-side rendering React, at least in the trivial cases. Everything is, with performance, it's always like, everything needs to be measured. So I don't want to say in like the general case, it's always faster, but it is very fast. One of the optimizations I did here was the JSX transform is different than the typical React JSX transform. It basically inlines the function call that JSX does in the automatic transform, which was a 20 to 30% improvement. These are what, so like Bun is all of this is very new. I've been working on Bun for about a year, but it's a really big project, so right now it's like still really buggy, just being honest. So these are the priorities right now. Improve stability, improve node compatibility, make it easier to contribute, but also to make it so uninstall can actually be used for all the cases. Right now it doesn't support workspaces, it doesn't support GitHub dependencies, it doesn't support Git dependencies, it doesn't support HTTP tarballs. All that needs to be fixed. And this is what's next. One of the things I'm sad about is that I didn't have time to fix HMR before releasing. So it has live reload right now, but the HMR is really fast. Here's what, see, this is an old video, but you can use it as new bundler because I didn't have a name at the time. This is reloading a CSS file every 4 milliseconds. And there's no CSS animation there. That's actually just it loading, like hot reloading. And you can see like the script on the side is like kind of blurry because it's moving so fast. So this is like, this will be fixed and it'll be re-enabled. It's just, there's like, it's like some obscure bug that needs to be fixed. Oops, slipped ahead. Did not mean to skip ahead. Okay. There's a missing slide. Oh, right. Okay, so fix HMR, and then the next thing is ASG plugins. One of the things I was kind of sad about with this trend of new bundlers is that they tend to not have JavaScript plugins as a priority. It should be possible to do JavaScript plugins that are fast, AST plugins that are fast, that are easy to write, and that are powerful. So this is an example where basically it's visible. This function now that's selected in the bottom right there, that's run at build time in the transpilation time, and then you can see in the output on the left that it inlines the call, so there's no moment there. And this is in the JavaScript source code, or in the transpiled source code. So the idea is that this function is run in build time and the result is replaced. And you can see that this version uses a custom JSX transform. This is actually optional now. It also enables precise dead code elimination. So this GitHub API response is like a big JSON object. And then the transpiler detected that you're only actually using tag name, so then it only included tag name in the output. And so that saves a lot of space. This is another thing you can do with it is you can pass objects to it. So in this case, we pass a JSON object, and then this is in a test, and then we can see that the output, because it called .text on the release. Oh no, that's what. Sorry, I remember now. We call .json.url on it, and then it detected that the only thing that it needed was the URL, so then it only returned the URL as a string. And more broadly, it lets you inline data at bundle time. So this is a case where you fetch a CSV, and then you see the output is the CSV in the file. And the way this works right now is you have a macro colon, or as in the module specifier, it starts with macro colon, then it knows to execute that at build time. But I think this needs to be changed to be a little simpler. I don't like this colon prefix thing. That's also part of why it's not documented yet, because these are it's very rough around the edges. This is an example of a relay plugin. This uses the JSX transform version. So you can see that it has an import statement that you insert that's injected at the top of the file. And then we have an identifier with the name pointing to whatever the definition name from the GraphQL parser. This is actually in in Bun's repo under Bun macro relay, I think, in packages. And I think it's possible that this will inspire a bunch of new JavaScript frameworks once it's more stable, because you can move code from runtime to build time really easily, and you can use it like a normal function call. So it's like a very small API service. That's all I got.
All right. Anyone have any questions for Jared?
Hey, I know we talked about this a bunch before, but I'm really curious. With so many different areas that Bun is well outperforming competition, what do you think like the biggest strengths are that should be focused on for us as users of Bun? And more importantly, how are you using those different strengths to strategize as you continue expanding Bun in the future?
Right now, I would say the easiest way to use Bun is Bun run for running package JSON scripts, because there's no, you just try it and it saves you time every single time you run it. Bun install is probably the second easiest thing to run, like to use, because assuming that you're mostly just using npm packages and not like GitHub packages, and that just saves time as well. Longer term, the runtime will be more of the focus, but it's just a really big project, and like the runtime part is just going to take longer to be stable.
I think in that what was your inspiration for Bun, and when did you actually come up with the idea and start working on it? Like I would as like a time marker, like when Ryan Dahl, the creator of Node, gave his talk, what was it, the 10 things I hate about Node, and then introduced Dino. Was it before or after that? Or was there any other, was that within your universe of inspiration for this or no?
No.
No, okay.
Basically, I've been like really frustrated with how slow JavaScript tools are for like a while. And I was building a game. It got to be like 100,000 lines of code or so, and just the iteration cycle time got really slow. So then I started working on the build tools for the game, so that way I would be less frustrated building the game. And then I just spent more and more time on the build tools, and I was like, well, okay, I should just work on the build tools.
Classic. So how long has that been from that point until today?
I think my first commit to Bun was April of last year.
Wow.
Should the game turn out good?
No.
Kind of reminds me of Redux, the story that is. Anyone else? Any other questions? Yes.
So I want to ask about Zig, but before I do, I just wanted to say that the other thing you didn't mention that's really fast is Bun with test. Like when I first ran that, and compared to Jest, I was like, holy cow.
Yeah, I do want to focus on that, but that will be a focus, I think, in like a couple months. But it's sort of like the runtime needs to be a little bit further along, I think. Like it needs to be a VM polyfill, but I know it doesn't have a VM polyfill, because if you try to use like JS stuff, it doesn't work. So like those sorts of things need to be fixed.
True, yeah, I was testing plain TypeScript and it was so fast.
Yeah.
But my question about Zig was, what are your thoughts? Now that you've used Zig like heavily and you're committed to it, what are your like? How do you feel about that decision? Like, should we all go home and learn Zig? Like, is it awesome?
Zig is great. I think that it's very good for writing fast software. It's very good for the error handling is very interesting. The control you get over it's very good. It's a very good systems language, and the interop with C is fantastic. So it's like that's a part of what made Bun FFI. So like Bun has a way to call. Like Bun has NAPI support, but it also has FFI, which lets you call arbitrary C libraries or C compatible libraries without actually writing bindings yourself. And that's also really fast. Zig's model makes something like that a lot easier.
Anyone else? All right.
So you run bun install. What under the hood makes it faster than npm install? Is it the better system calls? Is it the hard links? Explain it like on Python, I guess.
It's a bunch of things, but the main thing is that it's mostly the system calls. You could get kind of close to the speed if you use the exact same system calls in JavaScript, but the issue is that the system call, the actual overhead of doing any system calls in JavaScript, when you have to do it on like a per file basis, because there's npm packages have like a crazy amount of files. So if it's a function call for each file, then it costs like, I don't know, like 10 nanoseconds extra for each call, and then you have all the node stuff for like for in the API itself to like detect did they pass the file name correctly, and then for all the system calls themselves, you have to add a 0 to the end of the string, and then you have to convert it from like Latin 1 to UTF-8. There's just like a lot of overhead when you're doing stuff like that in JavaScript, unfortunately. Some of that I think can be fixed, particularly that Latin 1 thing. It's actually really annoying because like text encoder you shouldn't really need to run text encoder. It should just be that for the common case of using UTF-8, it should just be that the engine stores it in the way that every other piece of software in the world mostly uses. It's just like JavaScript has, because charcode add, sorry, this is really in the weeds now.
I love it.
Charcode add returns as Unicode or as UTF-16 code points, code units. Because of that, you have to, if you made it all the JavaScript strings UTF-8, you would have a performance problem because you'd have to re-encode it as UTF-16 in order to be compatible, and people expect charcode add to be really fast. But basically, a lot of performance problems in JavaScript would go away if strings were UTF-8. And also if strings are mutable. But that's really complicated.
I lost you at string.
Question about the organization of Bun. What is your current organizational structure, if any? And what are your plans for it or your desires for it?
Bun will eventually be a company, but right now it's mostly just me.
Are you looking for contributors?
Yes.
Are there any out there today?
Let the man sleep.
What is the next feature or features that you're looking for that you would like some help with?
That's a good question. Probably like one of the polyfills missing right now is DNS, like the node module DNS. That needs to be implemented. It would be cool to have help with that.
Yeah. And what about just docs overall?
Yeah, so docs need to happen. There's like, it's just a README right now, which is not good. It's a very long README. The rationale there was that you could make it so you can Command F really easily. But like, it needs to be like, it needs to be searchable, like on SEO. Like if you Google something in Bun, it should show up. I think that basically it's, I have like, I really want the docs to be good, but I don't have time right now to like invest in it a lot. So it's sort of like this bad. I'm basically the blocker on making the docs work, or because other people have contributed docs, but I really want to do like custom front end stuff for it to like make them really pretty and like make it a good UX, but I don't have time, so I'm kind of like, it's like net negative for me to be like that.
Yeah, definitely. You can definitely get the community to help with that. I remember Brandon Bayer, who created Blitz.js, he tweeted out the idea, hey, I want to create a Ruby on Rails for React, right? And then just like literally 6 months later, he has this beautiful site, beautiful docs, all this documentation, And it was just a community effort. So yeah, Twitter can be extremely powerful, so that's fine. But also Brandon's really great at all that. So any other questions? One more over here.
Is there anything blocking MySQL, Postgres, Redis support right now? Like if I
Sockets. No, it needs to be implemented. The plan there is to use, so Bun's HTTP server is based on WebSockets, and I think that was that's part of why it's really fast. And I think the same WebSockets uses usockets as their socket library. So then I think Bun should implement sockets that way, using that usockets library and then expose that. I have a lot of ideas to make that fast, but I think that the main thing is that once that's implemented, then it should be pretty straightforward to also add MySQL or Postgres. I kind of want Postgres and or MySQL to be like built-in libraries, like Bun ships right now with SQLite built in. I think that these need to be really fast, and I think they need to leverage as many optimizations as possible. Just because people use Postgres and SQLite, or Postgres and MySQL, it's a very important thing in their apps.
All right, everyone, let's give it up for Jared. Before we end the meetup tonight, I want to try something fun. Don't go anywhere. If I can have Ryan come up and Alex come up, I'm going to do a photo of all three speakers right there with the crowd behind you.
Oh, this way.
Yeah. And how about everyone stand up? Awesome, go with awesome. And then I want everyone behind the speakers. Speakers will look normal, and y'all are gonna just go crazy. 1, 2, 3. Is that crazy? I want everyone to go woo on 3. 1, 2, 3. Woo! Yeah, that was awesome. Great job, guys. Thanks everyone for coming out. Thanks to Convex for hosting. We're gonna be here for another hour and a half. There are still tons of food back there. There's tons of drinks. Feel free to stick around. We'll see you at the next one.
I've had that.
Can we get music? Can we get music?
Yeah, there.
Man.
That was great. Thanks for organizing.
It went really well.
That was so good.
I even got that from the...
I was like, special order podium? No, it's like a sticker.
We just ordered it in, and it showed up. Stop that off. And you know, lunch break goes in there.
Well, I turned around at the end of lunch, I saw it. I'm like,
Yeah.
So this is wide angle.